All right, so I think it's time for us to get started. So welcome everybody. Thanks for joining this workshop. Today we have 4 hours and we are going to spend it working on Rhino, learning how to use it and so on. So first of all, I'll start with some introduction and tell you how I imagine the workshop, what is the plan for it, what is the intended structure. So the workshop, as mentioned in the description, will be based on hands-on exercises, and we have 6 exercises for today. The plan is to have them in 3 blocks. So we will have, somebody says that they cannot hear. Just, okay, so sorry about that. I will continue. Hopefully they can resolve that problem. Okay, so today we have in plan 6 exercises, and I would like to do this in 3 blocks of 2 exercises each. So we will do 2 exercises, a break, 10, maybe 15 minutes, another 2 exercises, another break, and then 2 more exercises. I see Veda has joined me as well. Hi, Veda. So Veda is helping me today to address the questions that you might have during the workshop. In general, each exercise will start with a short introduction from me. I will tell you what to expect in the exercise, what are we going to learn in that exercise, and how to approach it. Then you'll get some time to work on it quietly. By that, I mean, during the time, I won't be presenting, I won't be talking, so that you can focus on the exercise. Maybe if I see that some questions are coming and there is some problem in the exercise, I will interrupt the time so that I can announce to everybody whatever issue comes up. And after the quiet working time, there will be a presentation of the solution for the exercise. What are you looking at right now is the repository where all the tasks are defined. And there is a directory for each task. Each directory has a README, which contains a detailed description of what to do in the task. So, by the way, this is not a competition. All the solutions, if you look into the history of the Git repository, you would find them, they would be visible. But I encourage you to try your best to do the exercises on your own. And if you get stuck, instead to ask questions to us. So, all right. There are a couple of options for getting help during this workshop. First of all, you'll be able to ask questions directly to Veda. He's here to support us, and he'll be able to answer questions directly. You can also write on the general chat, and I will be looking there also with help from Veda, so I will do my best to answer your questions there. And especially if something relevant to everybody appears, I will address it on the fly to everybody. And lastly, I actually don't see, I thought we would have a Slido maybe, so if you wanted to ask a question anonymously, it would be possible to do that through Slido, but we don't have this set up yet. However, maybe we can do it as the workshop progresses, so maybe it appears in the meantime. For now, the options you have is to message Veda or to write on the general chat. All right, I can see already somebody shared the repository that I'm showing you on the screen. My intent was actually to pin a message with that link somewhere. I'm not sure. So there is a Slido. Okay, yes, there is a Slido. Perfect. All right. Okay, so you got the link. If I learn how to pin it, maybe I will pin it, but hopefully you can find it on the Slack. Also, what I would like you now to do would be to copy all the, to clone the repository if you are familiar with Git. But there is a chance that, yes, the material will be available after the session as well. There is a chance that you are not using Git or not familiar with it. And if that is the case, you can also use the link that I will send you in just a moment. And this is an alternative way for you. You might download that zip file, unpack it, and you'll get all the files there. Okay, so before we get started, a couple additional notes. As I mentioned, the tasks are, we have six tasks, and each task is subdivided into steps. The tasks are completely independent of each other. Each one starts with a completely fresh Rhino structure that we will be working with the exception of task 1, which starts without structure. You create it on your own using Rhino initialize method. But other than that, each task is completely separate. So if you get lost at some point, don't worry, you can come back at a later point during the workshop, and you'll be able to continue from that task. However, within a task, the steps are interrelated, and you should do them in order. You might want to see what's coming next, but very often a step will depend on the previous steps, so you'll want to do them in order, basically. And the idea I had when designing these tasks was to create the steps in increasing difficulty order. So very often the tasks start with very explicit instructions, so you can get some first steps done and get a feeling for what you will be working on. But as the steps progress, they get more difficult and less information is provided. So it will be more challenging to complete that. And by the way, my expectation and intent is not for everybody to complete all the steps in each task. Rather, the idea is the following. For each exercise, you'll be given some time to work on it quietly. And depending on how familiar you are with R, Shiny, and Rhino, you will do more or less of those steps. The idea is for you to spend some time working on it, to see what kind of problems arise, to see what kind of issues you do not understand, and to ask questions during the time. So this is kind of an interactive tutorial if you wish. So don't stress over trying to get everything done during the time that we have reserved here. The materials will be available also after the workshop, so if you cannot finish it on time now, there is no problem. You can always come back to it later. So yeah, if you get stuck on any of the steps for some time, feel free to ask us. Also, feel free to ask questions if you just like to learn more about some particular topic, or if something is like not clear to you. I will answer the important questions right away and interrupt the silence that I mentioned. For some questions, I will probably answer at the presentation of the solution, because each task will be ended with a presentation of the solution. And I think the last thing to mention is the general structure of the tasks that we have here. Sorry for no global README here. So let me just fill you in. The first 3 tasks use only R and nothing besides that. So assuming that you have Rhino installed already, which was my hope, it was listed in the requirements for the workshop, but if not, we'll do it in a moment, so don't worry. So for the first 3 tasks, you only need R and Rhino, and that's it. The task number 4 is about SAS. You can still use only R because it's possible to configure Rhino to do so, but it's already a different language. And lastly, task 5 and 6 are about JavaScript. the task 5 is about Cypress, and task 6 is about JavaScript in more general. And for those last two tasks, you will need Node.js installed. If you do not have that, then maybe you'll be able to do it during the workshop. If not, I do see it as an option for you to only listen to that or maybe do it at some later time. Again, don't worry too much about it. The beginning, everybody should be able to participate. The last task may be more challenging especially for those who have no prior experience with JavaScript or those who came without Node.js installed. Okay, so let's finally get started, but just before that, I would like you to check two things for me on your machines. First of all, take a look at package version rn, and if it's something lower than 1.0.7, ideally install the latest version. You can do it simply by install packages rn. So that's the first thing to check. The second thing, check what version of Rhino you are on. Hopefully you are also on the latest version, and this is 1.7. Again, if you are not on the latest version of Rhino, then you just want to call install package Rhino to get the latest version from Chrome. And these are the two things that you need to ensure just to get started. Lastly, once you have Rhino installed, you'll want to run Rhino diagnostics. And this should return some information. And in particular, we're interested in this line. If this tells you something else than Node and some particular version, then it means that you don't have Node installed or somehow it's not working for Rhino. So this is the information that you might have problem with the later exercises. As we come closer to them, I will also provide a link to Node.js, so you might get some time in the meanwhile to install them. But yeah, for now, this is just informational for you. Regarding the minimal version of rn, there is no such thing for this particular workshop, in the sense that I'm not using any latest amazing features. I think it should work even with pretty old versions of rn. But if you are using an older version, you might run into some issues which might be hard to find out what the problem is then. So ideally, get the latest version. 1.05 should be totally fine. Basically, if you are on version 1 or older, you should be good. But I would just recommend you to, if you are not on the latest version, just install it right now. It will take just a moment and you'll be fine. Okay. Okay. So one last note, I won't be able to answer all the questions as I see them on the chat as I go. I will do it during the quiet time. Sometimes Vela will help me as well. Finally, let's get started with the first task. So as I mentioned, I will start each exercise with a general description of what to expect, and then I will give you some time to work on it. And during the time, you can ask for help, and we'll do our best to help you. All right, so this first task is an introduction. It will show you in general how to start a Rhino application, walk you through the basics of running a Rhino application. It will show you how to enable automatic reloading, which you probably want to use throughout this workshop because it will make your life so much easier and it will be so much faster and more convenient to work. It will also show you how to run some of the general tools that we have in Rhino. Everything is pretty well described in the steps, I hope. The first 4 steps are the foundations, you could say. Then step 5 through 8 are a little bit more advanced, you could say. But this is something that appears quite often as people want to use Rhino for their projects. In particular, you will often come with an application which was not written in Rhino, but just in vanilla Shiny. And the steps 5 through 8 kind of show you how to take a vanilla Shiny application and make it into a Rhino application. So I will end with just this simple introduction to this exercise. And this is time for you to start working on it. I am going to launch some timer so everybody can see how much time left we have for this quiet time planned. And during this time, feel free to mute or to just like switch tabs, and don't worry about the workshop too much. All right. So for this exercise, I will give you 15 minutes of quiet time. And yeah, feel free to focus on it, ask questions. Let's go. All right. So it's been 15 minutes of time for you to work on exercise 1. Wonder how far everybody got. So, okay, let's just get into the actual solutions. So whether you got stuck on some of the initial steps or got far or maybe completed the exercise, don't worry about it. You can now focus to take a look at the solution. I will now present it on the screen. And as I said, all the materials are available after the workshop as well. So feel free to do these exercises at your own pace at some later time. Just to emphasize once again, we do it this way so that you get a chance to work a little bit and see what kind of problems you have, and so that we can see what kind of problems you have and that we can better address them. Don't stress about how much you were able to do here. I purposefully created enough steps so that even those people who are really familiar with the topics here still have something to do. So don't fret if you didn't get far. All right, let's go into the solution. So, okay. Ideally, I'll have many screens and also present the steps that I will be now discussing somewhere. But I think I will have to do with just RStudio here, and I will look up the exercises on the side. So let's start with the first step. It is to initialize a new Rhino application. I will be presenting in RStudio. There are two ways to do this. One option is to create a new R project using this button here. And if you take a look at this new directory, there is new Shiny application using Rhino. And this is one way to do it. The kind of downside to this is that it always creates a new directory. You cannot decide to initialize a project in the current directory, for example. There is a second method, however. You can use Rhino directly to initialize a project from the terminal, and this is what I'm going to do. This works similar to, for example, renv, which also has an init method, and it initializes itself in the current directory. So let me just get to the workshop directory. Let's get to the task1 directory. And here, I'm just going to call Rhino init. Wait a moment. And just like that, we are done with step 1. Simply calling the Rhino init in the directory is all we need to do. Now I'm going to actually open the project that Rhino created for me in RStudio so that I can see what's happening here. All right, you can see that we have a whole structure of a Rhino application here. And this is what I wanted. Now, how do we actually work with it? How do we launch with it? So let's look at step 2. First of all, let's enable Shiny dev mode just by calling Shiny dev mode in our console. And this will do a couple of things. And in particular, it will enable automatic reloading of the application, which will be extremely convenient for the whole development process. Now, to launch this application, we can do one of two things. One is to just call Shiny run app on the console, on the terminal. And this is the method that I typically use because I often work outside of RStudio and with other languages. But as I'm showing you everything in RStudio, there's also another way. If you take a look at this app.r file, there is not much here. A comment tells you not to edit this file, but we can use it to conveniently run our application using this button, run app here. And after we do that, we get the default message displayed by Rhino. And to finish off the step 2, it asks us to edit this message and to see how this automatic reloading works in action. So where do we do this edit? Not in app.r, but instead in the main R file that's nested in the app directory. This is where the whole application, not including the various configuration stuff, but the whole application, all its source code actually lives here. And if we take a look at this file, this is where our checkout Rhino docs message is defined. And if I just edit it, just after saving the file, you can see that immediately this is reflected in our application. Super convenient. All right, step 3. Let's copy over some code to our main R file. So just copy it over. I just copied some text. I will just paste everything to my main R. I'll hit save again. And you can see that the application did not refresh. And an error in the console hints me what's the problem. There is no package called ShinyFluent. And as the step actually tells us, we need to install that package. And to do that, we are going to use Rhino package install function. This function needs an argument which tells which package we want to install. As we are missing the ShinyFluent package, this is the argument that we need to pass here. We'll be asked twice, once if we want to install it, and secondly, if we want to update our randlog file. I don't want to get into too much details here. We don't have time for that, but it does a couple of things, and I want to briefly mention that. First of all, it edits our dependencies R file. There is a line library ShinyFluent here now. This is a list of all the dependencies that are used directly in the application. Secondly, it installs the package into the project library, Rhino relies on Rn to create an isolated library for the project. And we can verify this, for example, by checking the version of the package. We can now see that it is available. If I tried to run that command a moment ago, it wouldn't work. And lastly,
Kamil, could you move the RStudio slightly up because your name is blocking the console?
All right.
The bottom left part of it.
I see. Just wonder how to best do it. I guess I'll have to manually size the window to accommodate this.
Yeah,
I think this will be good, right?
Yeah.
Okay, I'll try to not resize it by accident. All right. Okay, so we have installed the package. I was mentioning what happens when you actually run package install. The dependencies R file is edited. The package is actually installed. And also the rn log file is edited, which has a list of all the dependencies, not only the direct ones, but also the dependencies of dependencies with exact package versions. And this is what makes the project reproducible. Lastly, we want to actually see this application. So let's run it again. This time I can do it from the console, maybe. Shiny run app. And what we see is an application which displays some cool widget from ShinyFluent. Nothing more fancy here. All right. This is it for step 3. Now time for step 4. This step teaches you some additional comments from Rhino. In particular, first of all, let's launch Rhino lint R. This function doesn't need any arguments. By default, it will lint the whole project. And linting means checking if there are any discrepancies from the style code that is defined for Rhino applications, or if there are some other errors, and report all these errors so we can take a look at them. And just to take to give an example, for example, at line 7, it tells us that instead of an equal sign for assignment, we should use arrow. Basically, the linter rules here by default follow the tidyverse style guide with some slight adjustments and additional linters for box use statements that we have in Rhino. But other than that, it's mostly tidyverse. OK, so as a good practice, I'd always like to have all those issues fixed. If all the developers, even if it's just us working on the project, adhere to that, our code will look clean, nice, and very consistent. And this really helps in the long run to make sure that the application is maintainable and looks nice, at least to the developers. So to fix those errors, we don't have to do all of this manually. We have a suggestion. It's step 4 to actually use another function that we have here, which is Rhino format R. And this function needs an argument. We designed it this way. If you try to run it without arguments, it will tell you that the paths argument is missing. You can also take a look at the documentation and read on. You can see an example. You can see that it takes one argument. So we want to format this one file. So I will want to pass the path to the main R file as the argument here. So you just need app main R. And if you took a close look on our eyes, the file changed a little bit. Some errors were fixed. For example, the indentation and parentheses were fixed here. If we try to run the lint R function again, you'll see that there's only one more lint error now. And this tells us that we should not be using this kind of syntax for importing everything from a module. So for those of you who are not familiar with box use statements, the quick introduction is that the following statement is basically equivalent to Shiny Fluent, with some additional quirks and lots of stuff that I won't go into in depth, at least right now. But that's the point. And the main feature of Box is that it allows us to import exactly what we want and not everything. And this, again, helps to make the project maintainable in the long run. Makes it easier to avoid name clashes, for example, makes it easier to track where each function comes from, and makes it easier to understand exactly what dependencies each of your files have. So anyway, instead of using this format, which imports everything from Shiny Fluent, I want to change it to something that will be accepted by the linter. And to do that, if I take a look here, this is the only function that is coming from Shiny Fluent. I just need to import it explicitly instead. If we run lint R again, we can see that no style errors were found now. Awesome. So this is it for these initial steps of getting used with running the Rhino application and working with the tools for our code. Now, let's move on to steps 5 through 8. First of all, we are going to take a look at our main R file, and I'm going to rename it to app.r. So this might seem a little bit weird, but what I'm doing now, I'm pasting into this file what is basically a legacy or vanilla Shiny application. You can see that it uses library, it just defines URL and server, and then it has the call to Shiny application. And I wanted to include this in this task to just like give you a taste for what's possible here. And Rhino has this feature called the legacy entry point, which allows you to run this kind of application, a vanilla or legacy Shiny application, within the context of Rhino. And this is quite often needed if you want to port an application to Rhino. You might want to start with just moving the code over to the app directory. And by enabling legacy entry point, you'll be able to run it. So this legacy entry point that I keep speaking of is a setting in the rhino.yaml file. we need to add a new entry here. Call this legacy entry point, and we will need the so-called app directory. In the README, there was a link to a description of this setting in more detail. You can read up about it, but the general idea here is that now the application is treated as if it was a vanilla Shiny app. So now I can do again Shiny run app. Then I have some problem. Honestly, I'm not sure what's the problem right now. I saved it in main R. I was tricked. Thank you so much. I was tricked by RStudio because I renamed the file, but I still had it opened, and it seems that it was saved as main R in the end. Okay, let's delete this one. Thanks for help. And let's rename this file to app.r actually. And now it should work. Awesome. So another showcase of a widget from Shiny Fluent. And now the following steps are just a quick kind of demo of how you would transform this kind of legacy application into a fully fledged Rhino application. You can do this kind of step by step. And this first step will be to actually move away from this app nested in app directory to the format recommended by Rhino, which is having a main R file here. So let's rename it back to main R. Open it up. And I will no longer need this Shiny app because this part will be now handled for me by Rhino itself. And I will need to change my legacy entry point setting to say source. Now I should be able to restart my application, and it should look just like it did before. Hopefully it does, so it works. Step 6 done. Step 7 would be to not use library calls, and instead to use box, which allows us to structure the application using files in a more natural way, or maybe more modern is more appropriate, close to how other languages do it. So I will just replace these two calls with box use. And for simplicity now, I will simply import everything from these packages. This is not recommended long term, but as I am working with legacy code, this is no worse from what I had just before, just libraries. So this will raise some lint errors, which I will be able to fix at later point. So this is one thing that I want to do. And the second thing will be to change my entry point to so-called box top level. A quick explanation is that box, because now we are using box, and top level because our UI and server are not defined as a Shiny module, but instead they are directly passed to app to Shiny app object. So let's try to run it again. I need to use double column here, and it works. Perfect. All right. Lastly, we want to completely move into the Rhino structure. To do that, the last thing to do is to make the UI and server an actual Shiny module. And this means simply wrapping this in a function of ID and adding some additional stuff. So first of all, I'm wrapping this in a function of ID. And what I need to do now is to actually use this namespace function and to apply it to all the IDs that I have in my application. And for the server function, we need to do something quite similar. We need to define a function of ID that will wrap our function. And here, we need to call module server. All right. Hopefully, I did not make any mistake. This is much more difficult when doing git leave. Lastly, we also need to remove the legacy entry point completely. And hopefully, the application worked. So this is it for the presentation of the solution of task 1. So I will now jump straight into the other task. I saw there were some questions appearing, so I will monitor it during our quiet time and breaks, so I can answer the questions if any appear. Maybe one more comment regarding the questions which we do not answer. Again, don't worry about that. I will have some time after the workshop. If there is a need for that, I will still be able to answer some additional questions after the main workshop part. And if still there are more questions or there are unclosed topics, we will be able to address it asynchronously later on Slack or by other means. So do ask questions, even if you don't get an answer now, for whatever reason, we'll come back to you. All right. Let's move on to task 2. All right. So this task is different from the first one because we won't be creating a new Rhino application now, but instead we'll be launching an already existing Rhino application. And this task is about creating a couple of simple Rhino or Shiny plus box modules. And the idea is to teach you how this structuring of your code using box and direct files and directories works in Rhino, and how you plug in those various modules so that it works all together. So in this task, the first thing that you want to do is to run rend restore in the directory of the project to make sure that all the dependencies install. Then again, try to run the application using the stuff that you learned from task 1. Use dev mode, for example, and make sure that it actually works for you. And then you can just jump into the steps and continue working on it. As before, ask questions if you get stuck or you just want to learn more about some topic. So for this task, let's do another 15 minutes, and let's go. All right. So let's get started with the descriptions for task 2. But first, I wanted to answer some questions that I noticed on Slido. And also, there's quite an interesting comment on the chat now. So the comment is regarding how ShinyNS function, the namespacing function, is used. And as you'll see in a moment, it's actually used everywhere in main R and also in all the modules. It's not accurate to say that it's used in main R and not in the modules. Hopefully, this will clarify in just a moment. The basic idea in Rhino is that each portion of the application is defined as a Shiny module, even the top level module. And this is the unusual part, because a vanilla Shiny application uses the UI and server directly in the app, and they are not defined as a Shiny module typically. But in Rhino, we wanted it to be consistent so that even the main R, or top level module, is defined as a Shiny module. This makes it easier to refactor the code, for example. Very often you'll start writing code in main R, and as it grows, you want to split it out to move some portion of the code into modules. And then it will be very simple to do if main R is already a module, because you already use the namespace function consistently and so on. To address the 2 questions that I see on Slido right now, let me start. Okay. First of all, I will need to resize my RStudio again so that my name does not cover what I type in the console, I guess. Something like this. The question 1 is, how do we launch an application so that it opens in the viewer pane? If you want to do that, if you open app.r in Rhino, you see this Run App button. And if you click this arrow pointing down next to it, you have a couple of options. One of them is to run in window, in viewer pane, or external. I have selected viewer pane, so it appears here. This is quite convenient for me to present this way. That's one thing. The second question regarding Rhino format R. This is what we saw in the previous exercise. When you run Rhino format R, it will tell you, look carefully at the changes that were introduced. And the question is, how do we know what are those changes? So just say that this basically, and this is out of scope of this workshop, but you would be using Git to track all the changes in your project. So whenever you make changes, you would be committing them to a repository. And when you are using Git, whenever you make changes, you can immediately see what changes those are exactly. And in particular, when you run the formatting command, you will want to start with a clean repository. And after running this command, you will see exactly which files were modified. But this would be too much for this workshop, so I won't be going into Git details. So let's move on to the solution of this task. So I have already the task 2 opened, but maybe I will show just quickly how to do it if anybody had trouble with starting this task. As I mentioned, this one is different from the first one. In the first one, we created a Rhino application ourselves. And in this task, and in all the following ones, we already have a Rhino application created for us. So to open it, if you are using RStudio, we have this open project in file. And from there, we can select task 2. And we want to point RStudio to this task 2, our project. And that's it. I've already done this. I have already the project open here. So I'll leave it like this. Now, let's go over the steps of task 2. The first step is to run rand restore so that we get all the dependencies. After launching this command, it will show me what packages need to get installed, and I need to confirm that I want to do it. I know that for some of you this took a long time. I am sorry about that. I should have posted some kind of preparation comment at the start so that you could install the package beforehand and it would be fast for you now. As you can see, this happened for me almost instantly because all the packages were already installed previously and they were now just linked from cache. They are all cached, so this is very fast now to do. And this is another great benefit of using rnv. It caches the packages that you use, and in the future, when you need in another project use those same packages, it will be very fast to reinstall them. You are not downloading or compiling anything, just link them, and this is done. So the second thing to do to finish off step 1 is to, again, enable Shiny Dev Mode, just like before, and run the application. So the application is running. We don't see anything. That's OK, because if we take a look at the main R file, there is not much here yet. There is just an empty fluid page with stuff to fill in. So it is expected that we don't see anything here. So let's do step 2. First of all, go to app view hello and take a look at this file. So this file defines a Shiny /box module. What that means is that we have a file that defines 2 functions, UI and server, and both functions are marked as exported. And these 2 functions form a Shiny module. Again, this is not a topic that I will go into much detail here. It is out of scope of this workshop to explain in detail how Shiny modules work. But the general idea is that a module is formed by a pair of functions, UI and server, which take ID. And this ID introduces a namespace in which all the inputs and outputs will be contained, and they will not affect the IDs of inputs and outputs from other modules. This allows us to build a Shiny application from separate chunks that do not directly affect each other. And we can use any IDs that we want here without worrying that it will clash with some other IDs in a different module. So this is the basic idea behind the module. If you are not familiar with it, just keep looking and you'll get a feeling for what it is. So moving on, we have this module, and the step tells us to add this module to our application, to main R. So there are a couple of things that we need to do. We don't need to import this module because this is already done for us in this structure, but we want to include it in our application. And first of all, we will want to add this hello module UI to our UI. And notice that we need to provide the ID argument for this module, and this argument needs to be wrapped in namespace function, which is defined here. And again, this is the way Shiny modules work. What you need to remember is that whenever you use an ID inside the UI definition, it needs to be wrapped in this namespace function. And on the contrary, when we use IDs on the server, we generally do not wrap the ID in the namespace function because this is done for us automatically. This is a general rule, but there are some situations where you actually need to take namespace from session, but this is out of scope. So remember, namespace in UI, no namespace in server because it's applied automatically. So after including this, we should be able to save the file, and immediately the application reloads and shows us the module displaying the hello message. So we are happy. Step 2, done. Let's move on to step 3. Go back to the hello module, and what we'd like to do now is to add some input to our UI, just in this place. So I'm going to use text input function from Shiny to do that. Also, we need to add a comma here. This is slightly inconvenient, but hopefully it was clear to see for us. We'll add a text input. I will call this the idea of this input name. Again, remember about the namespace. And as you can see, the namespace function appears everywhere. In the main function, it's in the main module. It's a module, so it uses namespace. The hello module is also a module, so it also uses a namespace. We need to provide an input ID and a label. Now let's try to save it. And as you can see, an input appeared in our application. We're done with step 3. Moving on to step 4. Now we would like to use this name input to generate a message for the user. And there are 2 things that we need to do in order for that to happen. First of all, we need to add a text output into our UI. This is where the message will be rendered. Call this greeting. A comma is necessary again. Lastly, we need to actually render the message that we want. And we do it the way we do it in vanilla Shiny. So we access output, greeting, and we need to render a greeting, whatever greeting you like. For this demo, I will just say hello name and an exclamation mark. Maybe I will also wrap this input in Shiny required function. This way, this message will only render when actually some name is provided here. So let's test it. Hello, it works. Okay, and if we remove it, no message appears. That's what we wanted. All right, let's move on. Step 5. Let's go back to main R. And now it's our task to actually import 2 modules. I want to import the const module from logic and the favorites module from view. So let me do that and then talk about what is logic and view. So this is the first time this logic directory appears. And if you take a look at our application, and in particular in the app directory, there are a couple of directories here. And so far, we've been just working with main R, and we also used the hello module from view, which was already imported from us. And now we are using something from logic. So what are these 2 directories, view and logic? So this is a suggestion that comes with Rhino to split your code into 2 parts, basically. To put your logic, and that is everything that can be defined without using Shiny in the logic directory, and to put everything that is strictly related to Shiny and reactivity in the view directory. The idea is the following. Reactivity and Shiny functions for putting HTML tags and widgets and so on are very powerful, and you can build a very nice application with it. but the reactivity can also lead to a great deal of complexity. And if you've ever seen a bigger Shiny application, maybe you encountered a server function which runs a couple hundred file lines long, and that is extremely difficult to work with. And the idea is to try to, well, first of all, modularize your app so that you split your app to smaller modules and they don't grow that large, but also to keep everything that does not need Shiny and reactivity and things like that out of Shiny. And this kind of code will be more testable, easier to work with, and in general, easier to maintain. So that's why we have two things here. And in this example, the logic directory just has this const module. If we take a look, this is a simple module that does not even import anything. It just exports two variables, fruits and vegetables. And this is a good place to put this kind of stuff. This certainly does not rely on Shiny. This is just definition of some constants, and this is a nice place to put them. So now that we have imported this to main, we would like to use these two modules. And to do that, I will need to fill in this part in step 5. First of all, include the UI of our module. Let's call this one fruits, because I'm asked to call it with the fruits from the const module. If we take a look at the, not hello, but at the favorites module, you can see that our module, unlike the previous one, takes not only ID, but also two additional arguments, at least the UI does, category and choices. And these are the two arguments that we need to fill in according to the description of the task, comma. So we want to use category fruits and choices. I use the constant from the module that I just showed you, fruits. After saving it, the module appears. We have favorite fruits here. If I put some other string here, this would be used for the title. This is how the module is designed to handle various cases. And this is another example of why you might want to use Shiny modules. They make it possible to reuse parts of the code. It's not always possible. Very often, you will build your application out of modules, and those modules each will be used only once. That is also perfectly acceptable and very common pattern. You want to split your application into modules. Not every module will be reusable, but sometimes you will build reusable Shiny modules. And this is a toy example that shows you how this can be done. So we have included the UI here, but we also need to include the server so the remaining steps work for us. The server does not need any arguments, and also note again the fruits is not wrapped in namespace. All right, this is it for step 5. Moving on to step 6. To see what does it mean that the module is reusable, let's include it once again. First of all, it's UI, but this time for vegetables. And again, we use our constant vegetables. Saving doesn't work yet because I keep forgetting about commas, but now it does. And lastly, we want the server for vegetables as well, just like this. All right. Let's move on to some changes in the favorites module, actually. So step 7. First of all, we are asked to add a checkbox group input in this place, which will display the choices that were provided as an argument to the UI. and also a label which will use the category in some nice way. So I want to call it like this, comma. For the label, I will just say pick your favorite and whatever was passed as the category argument. Lastly, choices are just choices. After refreshing, you can see that the module now displays the various choices, just like we wanted. All right, step 8 goes into one other aspect of Rhino that I wanted to touch, and this is how to use static files in your application. And first of all, we are asked to copy over the files from the images directory, which is here, into a different directory. So let me just create the directory first. The static files in Rhino are kept in app static directory. As you initialize an application, there is nothing here but just a favicon, which is the small icon that is displayed by the browser as the icon for the page. But here you can put whatever static files like images and anything else that needs to be loaded by the page when it runs, and it will be available on the server. This is slightly different to vanilla Shiny, where you would have a www directory. This is how we decided to do it in Rhino. There's also another difference in that you need to be explicit when giving a path to any file that you include. It needs to have a static prefix. We'll see it shortly. Anyway, let's start by creating a new folder. We'll call it img. Now let's copy over these files. Okay, I'm sorry for my lack of proficiency of using RStudio. I typically use VS Code, so I will just use different methods of copying. These are the images that we will be displaying shortly. And I'll just put them in the img directory. All right. They're here, perfect. And what we'd like to do now is to actually display those images as we check the checkboxes here. And there are 3 places that we need to fill in to get this working. First of all, we have this images function, a simple helpful function which gets a list of file names, and it returns a list of Shiny img tags. The idea is to transform the names of the choices that were picked by the user into names of the files that we just put in that static directory. So what we need is this source attribute, and we need to build it using the static prefix and whatever subdirectory we included. But anyway, each file we want to be accessible, which we want to include, needs to start with static. The path that we provide needs to start from that, not from app or any from app directory, but from static. Now we put the name here, and we need is the JPG extension. Hopefully this is right. Lastly, we'll want to render these images, and the step instruction suggests to use the UI output and render UI. So let's do just that. And now to render the UI, just to test it, it works. I'm going to use the function, the helper function that I just filled in, images. So let's just do images. And I want to use the choices made by the user. So input choices. Let's see. It works. It's maybe not beautiful because it's not scaled or anything, but this is what we wanted to do. It looked a bit different when I was testing it on an external browser, but you get the point. All right. The last step suggested here is to implement a reverse module. But I think I'm going to skip this one because unexpectedly, or well, quite expectedly, in general, these presentations of the solutions are taking a bit longer than we have time if we want to cover most of the tasks. So I'll just briefly tell you what would need to be done in order to perform step 9. Well, basically, we need to import the module, add its UI, and call it server, obviously. And we need to define that module, and it consists of 2 parts again. First of all, there is the logic reverse. We have a function skeleton ready here. The task would be to implement this function. And then the task would be to define a reverse module. This time, this whole file is left blank for us so that you can rehearse again what it looks like to create a module. The basic idea is, again, you need a UI and server functions, which are exported, take IDs, and the rest of the structure you can just look up in those other files. So I just leave you with this here. Feel free to work on this task later. I can see questions about the answers to those tasks, and those won't be available immediately after the workshop because I will need to clean up a couple of things, but all the answers will be available. So don't worry about that. You'll be able to take a look at the final solutions and yeah, do it at your own pace at any later time. All right. So with these first 2 tasks, we are almost in the middle of the time plan for this workshop. I would like now to do a 10-minute break, and then we'll jump to the other exercises. And disclaimer, I can see it already right now. We'll have to skip on the last exercise, which honestly is not 100% ready anyway, so that's fine. And instead, I will just talk about how JavaScript is being used in Rhino and cover a couple of things. Again, those tasks will be available after the workshop as well, and I will finish up whatever was not finished yet. So you'll be able to do those in the future if you wish so. All right, let's have a break. 10 minutes. Thank you. All right, welcome back after the break. So, well, let's get started with the next exercise. Let me briefly tell you what this one is about. As somebody mentioned in the comments, it would be great to have some general description and maybe more in-depth presentation about the topics here. That's a good point. I will definitely take this advice next time I'm preparing such a workshop. And again, I also feel that maybe I have overestimated how much we can do and then how much I can present within this time, but well, please bear with me. Let's get into task 3 and let me start this time with some maybe more detailed description of what this one is about. So when we are working with Shiny applications, when we are building them, we will pretty much always need some kind of data that we will be displaying, working on, and so on. And where this data comes from differs between applications. Sometimes it will be a CSV file, sometimes some other still file in some other format. But one very common place to get data from are databases. And this task kind of shows you how to use a database when working with Rhino and when working with a Shiny application. There are also some additional concepts that I want to cover here so that we can kind of see how the various bits fit together. And there are a couple of things here. Step 2 is about modifying the config YAML file. And this one uses the config R package, which can be used to define configurations for various environments. And this is something very common in enterprise settings or in a setting where we have the application actually deployed somewhere. We will be defining various environments. Typically, we'll have something like dev environment, which will use either local database or a development database. We'll have a production environment that will connect to some external database with the actual data, maybe some additional environments like staging or testing or things like that. And this is what the config package can be used for. And it can be used to define configurations for those various environments in a YAML file, which, if you get used to it, gets quite convenient. This is the first step to kind of show you how config file works together with the config package in a Rhino application. Because when you initialize Rhino, it comes with this file and the package installed by default. Secondly, the step 3 shows you how to use a .renviron file to define environment variables. Because once we define these various configurations for various environments, the question arises, how do we change between those environments? You cannot just, or you certainly don't want just to edit some fixed variable in your code each time you deploy to a different environment. So the general way, and something that is used widely, not only in R, to configure whatever you're deploying, working with, is so-called environment variables. And in step 3, you learn how to create a file that will set a single environment variable, which chooses the configuration that we just defined in the previous step. Then, moving on. Now, how do we actually work with the database? Because there are many, many ways to do that, basically. And this task just shows you one way, also with a couple of simplifications. And instead of showing you the right or the only way to do that, I want to show one way to do it and point a couple of important things about this solution. And the first thing we do is we use the so-called database pool. Instead of connecting to database directly and keeping that one connection, we use the pool package, which is used to automatically create and reuse database connections as they are needed. And this is much better than just getting one connection, which can get broken, get stale, or many things can happen with it. And you'll have to manually handle that for your application not to crash. The pull package does many of those things automatically for us. So instead of thinking about specific connection, we think about a pool of connections. Whenever we need something from the database, we ask the pool for a connection, and it will return us one, and we can use it. Step 4 just shows you how to create a pool and shows you one way to weave it into your application. I think I've already seen a question where to actually define this kind of thing, like a connection or a pool. And the idea or the solution used here is to define it as a global object in a box module. And this way, globals might sound scary. If you are into software development, you might have heard that using global variables is typically a bad idea and leads to all kinds of problems. But this is one case where this is exactly a good solution, I think, because this is exactly what we want. We want our application to only have one global pool, just one such an object, which will be used for all the connections to the database. And one way to do that is to have a box module which kind of encapsulates that. And this is what you do in step 4. It also tells you how to test that manually before you start going into the details of further steps and implementation. Step 5 is about logging, because just in the step 6, we'll just I'll just explain in just a moment. In step 5, we want to add some logging in order to see what's happening with the pool. There are 2 functions in this db.r file. One is for creating a pool, and one is for closing the pool. This step asks you to add some logging, which will display nice messages as the application runs to kind of tell us when the pool is being opened and when the pool is being closed. This is just one example of how logging can make it easier to understand what is happening in your application, especially if you are running into some kind of issues. And well, this step just tells you how to do that. I won't go to more detail here. Step 6 kind of shows you the rationale for why logging might be useful. If you restart your session after doing the previous steps, you will probably notice some warnings from the pool package, and those warnings are about the pool not being closed when the R session was ending. And this is a bit an unpleasant topic, I would say, in R. I would say that, well, first of all, there is no one way to handle closing pool when the R session exits. And second of all, the ways that exist are not beautiful, at least in my opinion. This is just one way that I decided to use in this task. I think for a more general approach, I would probably recommend an R6 object with a finalize method, which would do what the snippet that I tell you to paste into your application kind of tries to achieve as well. Basically, the idea here, the snippet does 2 things. It registers a finalizer, which will run when the session exits. This is what this onExit true does. But it also adds an unload. This is handled by box. And this is so that when you reload the application during development, the old pool will be destroyed and a new one will be created. Otherwise, each reload would create a new pool, and you would probably run into some performance issue after a while of development without restarting your R session. Okay, lastly, steps 7 through 8 are actually using that connection and pool that we created. And step 7 tells you to fill in 2 functions in the data module. Again, this is defined in the logic, and the idea is to have a separation of stuff that uses Shiny and which does not use Shiny. In this case, we have already a DB module that handles database itself. Then we have a data module which uses the DB module to fetch the data, to do some filtering, and so on. This is just a toy example, so you could totally see those simple things directly in your application. But for demonstration purposes, we have it as a nice separate module here that is then used in the application. Lastly, step 8 and 9 are to actually use the functions that we defined first in the filters module, which is already created for you in the application, and then to, after filtering in the filtering module, to display the data in the table module. Again, I will remind you that the purpose here is not for you to be able to complete all these steps, because my expectation from the beginning was that people with very different levels of proficiency with R, Shiny, and Rhino will come here. So it's totally fine if you do just the first couple of steps or even the first steps. You can still learn some concepts from that, and you can learn other concepts later at your own pace. The goal is not to finish all these tasks here. The idea was kind of, if somebody really experienced comes, they still have something to do throughout this time that we have. And this is probably the most difficult exercise in this workshop, so I'm going to give you more time for this one. I'll start the timer for full 25 minutes, and let's go. All right, time's up for this exercise. So before I start talking about the solution, I would like to briefly address the new questions that appeared on Slido. So the first one, I guess it would be best if I had addressed it as we were working on the exercise, regarding the fetch group function, how to add that utility to the app. Basically, don't worry about that function. Treat it as an example / a functionality from a more difficult version of this application, of this exercise. I was removing parts of the exercise as I realized it's already complex enough and that are kind of the leftovers, but I decided to leave that function on purpose. You can kind of see how to work with the data by looking at that. So that's why it's there. But otherwise, it has no function. And another general question, what would be the best way to deal with the remote database and netcdf files? Honestly, I don't know about netcdf files, so I cannot answer this, at least not now. We'll take a look at the questions anyway after the workshop, so maybe we'll be able to address that better afterwards. But regarding a remote database, well, the point of this exercise is to show you how to use the config package and environment variables to make it possible to configure different databases for your application to connect to. And the general answer would be that you'll need to define a configuration for the database, the proper driver, and whatever arguments it needs, like host name, password, username, database name, and so on. And this will be kind of defined through the config file. Some of those fields will be further fetched from the environment variables in a similar way to how log levels are fetched. Maybe I will tell a bit more when I actually show you the solution. Anyway, you would configure a remote database in a very similar fashion to how this SQLite database is configured here. This just requires more arguments and a bit of caution. The point is you do not want to commit any secrets like passwords to your repository. All right, let's move on to the solution for this task. So I have RStudio here once again, and let's start with opening task 3 project. All right, and the first step is again to restore the library from the log file. Should happen very fast. And the next step is to run the application. And I might be... Okay, I saw that at various points, people were asking these questions, and I was wondering where this was coming from exactly. And this is probably where this was coming from. A quick disclaimer is that as I was preparing these tasks, my approach was to develop the task in its kind of solved state and then to remove portions of the code for you to fill in. And I might have made some mistake along the way. And this shows that I haven't tested this properly, so I'm sorry about that. But let's take a look. Boxus app main. Okay, I think I know what's the problem. Yes, we actually need step 4 for this one to work. I kind of removed the code, which is the steps should be in slightly different order, or I should have designed the structures slightly different, so we were actually able to run this application. But I think I leave it. Yes, I leave it as is, because if I was to run this application right now, we are not going to see much happening anyway. Maybe I will do just one quick fix, because the pool is not being used in data anyway. So hopefully I can run the application. All right. So I can run the application. The problem was that data module is using the pool object from DB. And the step where we actually export and define this object is step 4. So I will comment this out for a while now. All right, let's get started with the actual steps. Step 1, we managed to restore our end and run the application after a small fix. Step 2, edit the config YAML file. So I mentioned during the introduction what's the point of this file. The idea, to reiterate, is that in this file we can define configurations for various environments. For example, during development, we might be using a local database with some mock data, just like we were doing in this exercise. But we want the application to be easy to deploy without modifying the code to change the database it connects to when we deploy it. So the idea is to define as many configurations as we need. Very often it will be just development with some local database with mock data, plus a production with definition of how to connect to a remote database. Anyway, in this exercise, we are just defining configuration for development environment. And the step just tells us to paste some code here and then play with this config to see what it gives for us. So I have added this to my config YAML, and now what happens if I run config get? You can see that I get a list with 2 fields, Rhino log level and Rhino log file, and these are the fields that are defined here. So by default, when I run config get, I will get everything that's defined here in the default. And as I have only defined the configuration for development environment, but I haven't yet turned this configuration on. So by default, I only get the stuff here from default. I won't be going into very much detail. You can read on about the config package, so it's best to just see how it works in action. But now, as the step suggests, it's possible to say which configuration we want by passing an argument to the config get function. And that's when we do that, we'll get something more. In addition to the values defined by default, we also have the values that we defined by development environment, which is the DB driver and DB arguments as we included in this file. So this is it for step 3. Just define the configuration and see how it works. Let's move on. Step 3. This step tells us how to actually select that configuration that we just defined, because in the application, like if in the app we just started using config get with an explicit argument of def, again, we'd be stuck with that single configuration. We can't just use that in the code, because if we want to deploy it to production later on, then what? We'd have to modify all the places where we call this function and, for example, change it to production. But this is obviously not how this is supposed to work. If we take a look at config get, by default, the config parameter gets an a value from the rconfig active environment variable. And this is where the environment variables go into place. This is the mechanism that you use to actually configure the application for various environments when we already need that. So when we are running locally, we will configure it to use the development configuration. When we will deploy it, we will configure it to use the production environment in the way that is kind of thought for the place that we are deploying to. For example, if we are deploying to RStudio Connect, there is a place for each deployed application where you can define environment variables. And this is where you would put rconfig active and define whatever config you want to use. Anyway, let's actually do what the step asks us. And this is to create a .environment file with a single line. So let me create such a file. Like this. And we just want a single line here. If I tried to run config get now, still nothing happens. This file is only read as the R process starts. So that's why we need to restart our R session for the changes to take effect. So let's do that quickly. And if I try rconfig get now, you can see that by default, I'm getting the full configuration. This environment variable is now in place. I could actually see that by asking for the value of this environment variable directly. Before, it was undefined. So this is how we define configurations and how we switch them. All right, now what to do with this configuration? We are now going to define a connection to our database, actually to create a pool, as I mentioned, which is a preferable way to approach connecting to database. And for that, we'll go to our app logic DB module. All right, and here we are in step 4. I'm now going to use this create pool function to create pool in this place, step 4. And to do that, I just need to call this function. Now, there are questions. What is this conf parameter supposed to mean? So I admit that it might have been not very clear. I was actually, in various points, I was wondering how much hints to give versus not to give. My intention was for you to see we were just playing with the config, and inside we had defined the DB driver and DB args, as you might have seen. And the point was for you to notice that this function uses this conf this way. So this conf argument needs to be config returned by the config package. So I just need to, I have config already imported here, so I just need to call config get. And this is it. But I also need to remember about exporting this object. And I think this is another thing that many people stumbled upon. If you do not export this object, you won't be able to access it from outside after importing the module with box. All right, so this should hopefully work. Let's take a look. I'm still in step 4. I'm performing the suggested instruction to test if my module works. OK, something happened, no error thrown. So let's see if my object has a pool object. It does. And at this place, if I did not have this export, I would get an error. And I think that's what many people got when trying to do this step. Now, the steps also suggest to kind of play with it a bit more to see what's actually in that connection. And we can use the db read table from DBI. And I'm just telling you here that in this database, there is a table called favorites. And this table contains a data frame. This is a data frame which has a 100 rows. There are 4 groups of people, let's say. Each person has an age and their favorite fruit and vegetable. This is the data that we are working with. All right. So this is it for step 4. Step 5 tells us to use the log function already imported here for us from Rhino to add some logging. We can already see at this close pool function that there is some logging when the pool is being closed. This function is not used yet, but we can see how to use the log function here. So I'll just actually copy this over and rename it so you can see creating DB pool. Quick answer, because I see a question, why do I use the $ instead of double colon when I'm calling the functions in my code? And I guess there is additional confusion because when I'm doing stuff here in the console, I sometimes use the double colon as well. So this is related to the fact that we are using box in our application. And box makes kind of forces you to be very explicit about what functions and packages your file uses. For each file, you need to have a box use definition, which explicitly says which packages are imported, and sometimes also exactly what names are imported from that package. And this kind of declaration makes it possible to use DB pool and DB close directly without any further ado in the file that follows. For example, like here, DB pool. But when I have config, a package without importing specific names, I will need to use the $ to get stuff from it. And now, well, this is something that is kind of, well, not ideal, let's say. If you do this, it will actually work as well. But now this is kind of bypassing box. This is using the mechanism of arg directly, which allows you to get anything from the config package. And why do we use this and box instead? The thing is, if I start doing this, I'm actually now not required to put config here in the box use definition. And that means that by looking at the top of the file, I will no longer be able to say what packages are needed to run this file. So I lose this, this benefit of using box, that just by looking at the top of your file, you can immediately say exactly what packages and functions are needed. So that's why we want to use this, and this will then use the module loaded by box. If I did this, double colon, this bypasses box and asks R directly to get that from the package. Hopefully in the future, doing this in a box module will raise an error. But well, for now, you need to kind of know and remember that this is the way to go. Moving on, we are talked so much. We are adding logging. As I said, we already have the log function imported here. I added log info to this create pool function. And now, after saving it, I would like to play a little bit and see what happens. So the suggestion in the step 5 is to call box reload DB. It's another function from box, which allows you to, well, basically reload the module that was loaded earlier. And when we do that, you can see that a message that I just defined here appears, tells me that I'm creating a new DB pool. And if I run this a couple of times, you can see that each time I'm creating a DB pool. And you might get concerned at this point, what about this message about closing DB pool? Why is it not printing anywhere? And the quick answer is that we are not calling this close pool function yet anywhere. And this brings us to step 6. What happens if I restart my R session now? I get a ton of warnings from the pull package telling me that the pull was not freed. Again, the pull is an object which is responsible for keeping connections to the database. And it is important that after the application exits, or actually before it exits, at the very end, when the pull is no longer needed, we close it so that all the connections are properly closed. Oftentimes, it really does not matter that much, but for the sake of good practices and for the various cases where it can actually matter, we should always close the pull when we are done using it. And in this case, as we are using one global pull object for our whole application, we will try to close it as the R session ends, or if the box module reloads. And this is what the snippet proposed in step 6 is about. Again, this is something that I'm not going to go into too much detail here. As I was explaining the task initially, I told you that this is not an ideal solution because it's not, well, very pretty, and that I would probably recommend you to instead wrap this in this pull in an R6 class and define a finalize method for it, which is, I think, slightly better, slightly cleaner, and you can also do cool stuff with that R6 class. But I figured this is too much probably for this workshop, so I left it as we have here. So just give a quick short explanation about these two things. Reg, like register finalizer, allows us to take an object and define a function that will be called on that object when R exits, and or when that object is destroyed by R, whatever that means. The on exit tells us that this function should be also called if the object is not destroyed when R is exiting. So by calling this function, we ensure that when R is being closed, we will call close pull on this pull object. And now this onload function is a functionality of Box. Box allows us to define such a function and add some cleanup code here, and it will run it each time it unloads this module. So when the module unloads, it will close the pull. And we unfortunately need both if we want application to work nicely during development, especially if we enable Shiny dev mode. It will reload all the time. And if we don't close the pull each time the module unloads, we'll keep creating new pulls and connections to the database, which can become a problem. Maybe not finally when the application is deployed, because the module won't be typically reloaded at all. But during development, it can lead to resource leak and the application working slower and slower, just making the development a pain. So anyway, we need these two functions. Let's try to, again, Box play with steps 4, 6 again. That means basically, let's try to Box use the DB module again, and let's see what happens. You can see that after importing the DB module, we are creating a pull. What now happens if I reload the DB object? You can see that the pull is first closed, and then it is created again. If I keep doing that, the same thing happens again and again. If I restart my R session now, you can see that before it actually quits, we close the pull and no warnings are printed from the pull package. So we were able to get rid of them. The pull is now properly closed. All right. And this is it for how we define a configuration for different environments and how then we choose one of those configurations and how we kind of utilize a database connection in our application. Now it's actually make use of the data and do something with it. So let's go to step 7. Step 7 asks us to fill in the implementations for these two functions. I should have probably added some documentation to explain you in more detail what these functions are supposed to do, but it's too late for that, so I'll just tell you now. Fetch favorites is a function which, as you can see, takes a group, and if you run the previous steps, you probably have seen that our data frame has a group column. So the idea here is to only fetch the rows for the selected group. And now, a rationale for why this exercise is designed this way. Imagine that we have a database which has millions of rows, and there are many groups. Like each row has a group assigned, and fetching all the whole table is too much. Millions of rows will be hundreds of megabytes, if not more, of data. Instead, we'd like to fetch one group at a time, whatever user has selected at some earlier point as the application is running. By the way, that was the more advanced version here, where with some additional filter, the user would be able to first see what groups are available and then to select which group they want to fetch. And we only would fetch that group. But OK, in this case, we just have this function. This one won't be used in this exercise. And the idea here is to fetch just the single group. And yeah, the idea is that we cannot fetch all the data, but we can fetch it for just one group. So that's what we are going to do. And the exercise suggests us to use a couple of functions from dplyr. So I'll just, the dplyr is already imported for us here. By the way, I will also need to uncomment this line now. So let's just jump into implementation. All right. So first of all, dplyr table. This is how we refer to a remote table. So normally we would work with a data frame, which is plain our object in our memory. But the idea here is that we don't want to first fetch all the data, but instead to fetch only the data for the given group. And this is possible with using dplyr, because if we pass not a data frame to it, but instead something wrapped in this table, and in particular, I want to, first argument is the source. It's like the database connection. And the second argument is the table that I want from that source. If I pass something like this to dplyr, it will actually not fetch the data first and then work on it, but it will instead generate an SQL query that will be executed on the database, which means that I will actually only fetching the data that I want. So this is just a, you could say, fancy way to refer to this data frame. Now, I want to get just that group. Simply, I'm going to use dplyr filter. Now, how do I filter by column group? I want the group column to be equal to the group argument passed here. But if I do this, I'm going to get all rows, because in both cases, this is interpreted as the column group. And dplyr will just compare the same thing to the same thing. So it will be true for all rows. To make a distinction, I can do this. Now it tells dplyr explicitly to use group column. And now by doing this, I can tell dplyr explicitly to use the group variable. Of course, I could also have changed the name of this variable, like a group. And this would remove the ambiguity as well. But I wanted to show you this thing. In some situations, especially if making more complex functions, like the column to fetch is not known up front, this is a very useful thing to know that such functionality exists in dplyr. And lastly, after filtering, we also need to actually tell dplyr to get the data frame. And this is done by calling the collect function. Again, not going to go into the details. You can read up on that. This makes dplyr basically complete the SQL query and execute it and fetch the data from the database. All right, let's see if this works. So I'm going to import just this module. Okay, no errors, at least when importing. Let's fetch favorites for group 1. Looks good. We have a table, group 1. Looks like the thing that we wanted, and just 25 values. So it seems it does the job. Okay, and the second thing to define here is the filter favorites function. This one takes favorites as an argument. Again, I'm sorry for not having at least a short documentation here, which would make it more explicit what is expected from here. But the idea is the following. We separate the function which actually does something to the database, and this one is called fetch for a reason, just like this fetch. It connects to database, from function which simply operates on the data that is already in memory, and in fact, which is passed here as an argument. And this way, as I kind of mentioned previously, we can do things like that. Because it might be a too big table to fetch all the data at once, what we might want to do is first let the user select which group they want to fetch, and then fetch just that group. And only after fetching the data, we can work with it in memory and filter it according to further users' needs. And this will be very fast because it's already in the memory, does not involve further calls to the database. So that's the idea behind this separation here. So the filter favorites function is supposed to take favorites, a data frame like this one, and return all the rows which have age, at least mean age. So to do that, we simply do it like this. No need to collect here because we expect this to be a data frame, so this should work. Okay, let's try to reload our module. And let's try to, okay, let's fetch favorites first. That worked. And let's try to filter them. Let's say people of age at least 50. Okay, it looks good. If I put 69 here, nobody, 65, okay, there is at least one person. Looks good. So this is it for step 7. We have these two functions defined now. All right, let's move on to step 8, and this is to use these two functions in our filters module. So the idea is to use the functions that we just defined. We already have the module imported here to create, well, first to fetch the data and then to filter it according to this input. Well, this step is already somewhat underspecified. I was at some point worried that there might be not enough to do for some people during this workshop. After testing it probably too late, I realized that's probably not the case. But anyway, this is what we have. Let's implement this step. So first of all, I want to fetch the favorites table. And the exercise just tells us to do it for group 1. Normally, we would have another input that would allow us to make a selection, which group we want to fetch the data for. And what I will do, I will just save it into a variable. And a point to note here is that if I write it this way, this will happen just once after the session for a user starts. So each user who connects to our application, this server function will execute, and we will just once fetch all the data, and we'll keep it in memory for the rest of that user's session. Now I want to filter this data according to the minimum age input. So I will define a reactive, and I will use the other function that I have in my data module. And I will just pass in this frame that is defined here. And now look, this is important that I do it like this and not like this, because otherwise I would be fetching the data each time I am modifying something about this input. And this is not what I want. I actually want the data to be fetched only once, to keep it in memory, and then to quickly filter it without further connection, without further requests to database. And we just pass the minimum age, just like this. All right. And now, as I said, this step and the next one, together they are probably more complex than they could be together. Now I would like to use this table module to display the data. So I still need to do some stuff. I need to go to my main R file. Here, hopefully, filters and table is already imported, but I still need to add the UI and server, all those modules to my application. So for the sidebar panel where the filters should go, I'm going to include the filters UI. And for the main panel, I'm going to include the table UI. Let's, at this point, run our application and see if there are any errors, and maybe we can fix it immediately. OK, we don't get any errors. Something is displayed. We didn't call the server, so obviously nothing is happening yet. What I can do, I can also let it reload automatically. Now, I will want to call the server function of my filters module. And the way I defined it, it returns this reactive, because this is the last expression in the module. So I want to save it to favorites, because I will need it to display. And if you take a look at this module, it takes the favorites table as reactive. By the way, it's important to notice as an argument. So I just need to pass this in. And hopefully, my application now displays what I wanted it to display. But it's hard to read. So let me show you this time how it looks like. We have an application which displays a table, and there's a filter. If I play with it, you can see that the filtering happens as it should. All right, so this is it for this task. We are close to the end of the workshop. So, and this task was pretty long, so I'm going to make a bit of a change compared to what I was explaining at the beginning. So I would now like to do a 10-minute break, and then we'll jump into exercises 4 and 5. We'll do a bit quicker round of them. And at the end, I will also just present you a bit about exercise 6, if the task allows. The exercise 6 was about JavaScript in Rhino. So let's see how much time we have left. For now, let's have a 10-minute break. Or after a second thought, let's have a 5-minute break. Oh, like this.
Camille, you're muted.
Thanks, brother. All right, we still have about 45 minutes left. And as I said, I would like to still follow the approach of letting you do some quiet work on the exercises, but we'll skip the sixth one and just do exercises 4 and 5. I see a couple of questions that I would love to address right now, but we will surely run out of time if I do. So let's get straight into the next exercise. And as I mentioned earlier, after the workshop, I still have some time, so I will probably just address those questions immediately. If anything gets unanswered, don't worry. We'll keep track of that and probably publish some list of responses or something like that. All right. Next task, task 4. This will be a change of pace. This one will be shorter and hopefully somewhat simpler. And it's about SAS. As you might know, the underlying technology on the web, which makes the web pages look the way they look, is CSS. And when you are building Shiny applications, very often just at the beginning, you won't worry about it at all because you'll be using some default functions that will handle the styling for you. Maybe pass in a couple of arguments or use some BSlib to change theme or something like that. But sooner or later, if you are doing some serious web development, there's a good chance that you will need more customized functionality and that you'll need to write your own CSS. And Rhino comes with a solution that allows you not to write just plain CSS, but something more cool, which is called SAS. The article linked here at the task 4 tells you about the basics of what this is, and I recommend you to open it as you now take a look at this exercise. But I'll just, as a word of introduction, quickly say that this is an extension to the CSS language, which allows you to do a couple of cool things like structure your style sheets better, to modularize your code into multiple files, which is very important if your style sheets start growing. You can use variables. By the way, some of these features, if not many of them, are now better and better supported by actual CSS. The latest standards really, for example, they do have variables also. But still, here I will be showing you a bit of SAS. So it has a couple of cool functionalities, and this exercise is here to just give you a taste of what's available compared to vanilla CSS. And I think without further comment, I'll give you, this time, just 10 minutes for this exercise. I wonder, yeah, I think let's just get started. there is a very important thing that I forgot to mention at the beginning here. So I will actually stop this for a while. The previous exercises were strictly about R, and if you just had R and Rhino, you could run them and you wouldn't have any issue with that, hopefully. This is the first exercise, which by default requires you to have Node.js installed on your machine. And this was mentioned at the requirements or recommendations for the workshop, at least I hope it was, because probably installing it now might be too much time. But exactly, it is possible to still do this exercise even if you don't have Node.js. And you can do that by, I will show it here. If you just change this configuration from SAS node to SAS R, just like this, then you should be able to do this exercise, where it tells you to run Rhino build SAS. If you don't have Node, it won't work. But if you make this change, it will use the R package instead. So you should be able to complete the exercise. So hopefully, if there is anybody who stumbled upon this, you get a chance now to still configure this and maybe try doing maybe it. All right. All right. Let's get started with the solution for this task. First of all, let me open it. And by now, you should get used to starting work on a new Rhino project with rand restore. So this was not mentioned in the steps this time, but actually maybe it should have been. But yeah, the first thing that I want to do whenever I start working with the Rhino application is to make sure that I can actually launch it. So I will restore my rn. I will also enable dev mode. It will make things simpler. And I'll try to run the application. All right, something appears. There is a hello message at the center of the screen. So it's something we can work with. All right, so the first step is to open the main R file. And let's take a look here. It tells us, the step tells us to move the inline style, which is this thing, to a center class defined in a different file. So let me just quickly tell you what's the idea behind this exercise. Inline style, which means basically attaching an attribute to whatever HTML tag you're working with, called style, and just putting some CSS there, is a practice that well, has pros and cons, but in general it is discouraged because it makes it quite difficult to make sure that the styles are consistent, for example. If you wanted to style your whole application this way, and you'll probably end up copying and pasting similar style string into many places. Of course, we're working here in R, and you could probably put this in a variable, but that's probably also going to get a bit messy. So the general recommendation, again, without maybe going to a whole lot of philosophy, is not to use inline styles, and instead to use classes to style whatever you are working with. And this exercise just tells you to remove this not so good practice and replace it with a slightly better practice, which is to define a class. And we are going to do it the right way, which means we are going to use Sass. In Rhino, we start with the app styles main SCSS file. And this has already some structure predefined for us. And this is where we need to move this code. OK, just like this. Now, this is a definition for a center class. Again, we could do a whole workshop on CSS. So if this is not familiar to you, I'm sorry, but I'm not going to go into the much detail because we definitely don't have time for it. But you can at least take a look at what's happening so you get a taste of what Sass and CSS is. Anyway, this is a definition of the center class. And now, instead of having this inline style, I can replace it with a class tag and use that class. Now, if I save my file, you'll see that my hello message is no longer centered. And this is because in a Rhino application, the main SCSS file is not loaded by the application directly. Instead, by calling Rhino build Sass function, we create a minified CSS file which compiles everything that we have in this directory into a single optimized file that is loaded by the browser. And to create that file, we will need to call Rhino build Sass function. But actually, it's possible to do it using something which I might as well show you. OK, I won't show you how to use an add-in because for some reason I can only see one add-in here now. Maybe some problem with my RStudio. So instead, I will stop my application and call Rhino build SaaS here, just like it's mentioned in the task description. And as you can see, my default configuration uses Node.js here. As I mentioned during an interruption to this task, it is still possible to use the SaaS the way it is defined here in Rhino by going to your Rhino YAML and setting the SaaS option to R instead. But in this case, I will be using Node, and this will be an opportunity to tell you a couple of things about it as well. You can see that as we launched this command, it took a while to install the packages and initialize it. It's actually still quite fast because I already had those packages in the past cached. But you'll see that now, whenever I run this command again, I will be waiting no more because everything is already cached and installed. So it will be very fast. It was only the first time that I was running this command. After running it, a file is created for me automatically in app static CSS directory. And this is the minifiled file that I was speaking of. And I actually don't need to do anything to include it because Rhino includes it automatically. I just need to run my application, and you can see that the text is centered again, but this time through a slightly better method. Now, step 2. We are just going to take a look at one other tool that comes with Rhino, designed to help you to work with those SaaS files. And this is the lint SaaS function. If I run it, it will tell me there are a couple of problems with my file, but hopefully, if I run the same function with fix true, you can see that some stuff changed around in my file. For example, the formatting changed here, and hopefully no more errors were reported. So this is a similar tool to what we saw for R when we were working with lint R and format R. Here we have just lint SaaS and lint SaaS with a fix true flag, which can be used to automatically fix many errors and style your file according to best practices. And this is it for step 2. Step 3. Let's just take a look again at styles. And let's take a look at the base module. So this is a module which defines a couple of things, these 2 variables, and also some mixing. This is for step 4. For step 3, I'm interested in the 2 variables defined here. And I'm just going to show you how to use that. Simply put, we include the file in our main CSS with the use directive, call it. And then we can refer to the variables defined here like this. So you can see I'm using the variable here, and its contents will be kind of pasted into this place. I'm passing some additional arguments for font in this case. Similarly, if I want to use the color, I do it like this. And a quick rationale for why we do that. Instead of using this value that we have here, like primary color, and just pasting it in each place where we need that primary color, we can define it with some meaningful name and use it throughout the application. So if in the future we want to modify it, it will be very simple, and we'll just need to change it in this one place. And it will be automatically used everywhere where we use this variable. Now, to see the changes, we need to build our SaaS again. Now, normally, I wouldn't be, if I'm working with SaaS, what I would do, I would instead use this watch through argument. And what this will do, it will keep rebuilding the file whenever I change it. So if I modify it, you can see that the file is recompiled automatically. And I would keep this process running in a separate tab, for example, by using an add-in to launch it for me. But for some reason, this is broken for me right now. If I worked outside of RStudio, I would probably launch a separate terminal and call this command there, so that in the background, I have build SAS running and rebuilding the file for me all the time. And in the foreground, I will have my application running, and I will be able to see the changes immediately all the time. But now, for technical reasons, I will just switch back and forth. Anyway, we can see that after including these variables to style body, the text here changed color and the font. All right. And the last thing that we are asked for is to use the gradient mixin. And again, this is a bit like a function. It allows you to take whatever CSS bits of code you want to use and include it in as many places as you want. And you can even define some arguments, so you can make it even more reusable and configurable. Anyway, to use mixin, we use the include directive and refer to the mixin in a similar fashion to variables. You can do it just like this. Rebuilding. We can see our cool gradient applied. I could also pass some argument here, like this. If I now again rebuild and we run, we'll have a different background this time. All right, so this is it for the quick demo of SAS. Top of main CSS, here you go. And the last exercise is to showcase you a special feature of Rhino that you'll probably not find anywhere else in the R world. And this is end-to-end testing with Cypress. And we have only 15 minutes to do that. So I wonder, I think actually it will make more sense if we'll wrap up the part of the workshop where you do the exercises on your own and just go straight into presentation mode. Because if I let you work on this now, probably you won't be able to do much, especially if you are not familiar with JavaScript, because this is a JavaScript technology. So let's wrap up the workshop part right now. And this is the presentation part where I will tell you a bit about some additional features of Rhino. I should have probably planned this workshop with smaller tasks or less topics so that it would fit. But I have this prepared already, so I'd like to just give you a taste. All right, let's take a look. Task 5. As I mentioned, the goal of this task is to give you an introduction to Cypress, which is kind of a unique feature of Rhino. Rhino, as already briefly discussed, uses Node.js underneath to provide you a couple of functionalities. Tools for working with SAS, with JavaScript, and also for end-to-end testing. And OK, first of all, what is end-to-end testing? Maybe not all of you have heard of it. End-to-end testing means testing end-to-end. And in case of an application, of a web application, the idea is to launch it with all the necessary data, connections, whatever it needs to actually run and perform its function. and to interact with it, to click through the interface, to type in values, and to verify if it behaves the way it should. There's a package called ShinyTest2, which is an R package, and it can be used to create this kind of end-to-end tests. However, it does have some limitations. It is designed specifically to work with Shiny applications, and it bypasses some of the interactions, for example, by setting input values directly. And in some situations, it is important to actually not bypass anything and actually do the clicks, actually do the typing in, and Cypress can do that. Cypress also is generally a widely used technology, which means that it has a pretty good support, and it's designed it's quite powerful, in short. You can do many things quite easily that would be impossible or very hard to do with ShinyTest2. Maybe it goes for more advanced testing, but also for simple stuff, it actually is very helpful. It's very easy to write simple tests in Cypress, and I would like to show you that with this short presentation. So let's just do this. Let me just do this task for you. So let's start with opening the project. All right. As usual, let's grab the necessary packages with rand restore. Let's enable dev mode. And let's see what we got here. OK, so we have this kind of simple application. And the goal of this task is to test this application. First, let's see what it can do. If you type in some name, it will display a hello message, very much like in one of the first exercises. And if we check all the checkboxes, it will congratulate us. An important point to note is that if we rerun this application, a different number of boxes might appear. I can't seem to get it now. Ah, amazing. So the number of boxes that appear here is random, and this is done so we cannot hard code the instructions to click the boxes. So that you can see some cool feature of Cypress, which makes it easy, for example, to select all the matching elements from some CSS selector. So this is our application, and the task is to test it. And in this case, all right, first of all, let's see what we get by default. The task is to run Rhino test end-to-end, and let's see what happens. We start with, again, with installation of Node.js. This only happens the first time you call a function which depends on Node.js in the given project. Afterwards, the function will run very fast because Node.js will be already installed there. All right, and it's printing some output. If you took a look here, it's running our Shiny application and then running some tests. It says that all 3 tests are passing. There are 3 tests here. However, the tests need to be completed. So right now, they do pretty much nothing. So that's why they pass. Let's also take a look at test end-to-end with interactive argument. And a window like this one appears. I have two options here. I'm interested in end-to-end testing. And let's stick with the default choice here, which is testing with Electron. And this will launch another window for me. This is kind of Cypress console. I can see just one thing here. This is the app Cypress.js file. This is where our tests are defined. Let me just show you what it looks like in the application. In the tests, we have Cypress directory, end-to-end, and here is our file. And this is where we are going to define a couple of tests for this application. Right now, it only has this before each, which basically means that this step of visiting the root page will be performed before each test, and 3 tests which currently do nothing. Our first task will be to verify if the application displays a title properly. And by the way, let's see what happens right now if I run this test. OK, you can see that it ran all the tests, and it shows me that they are passing. I'll just keep it like this and edit my test file. OK, so what I'd like to do is to verify if my application displays a title. And let's take a look to make things simpler into our main R file. There is this title panel with Rhino app, and I would like to check if this title is properly displayed in the application. This at least confirms that the application starts and renders something. It's not a very powerful test, but it definitely shows something. So to write such a test, I'm going to do it like this. All the comments from Cypress start with this CY, and then we can just write comments for Cypress. And one of the comments is contains. If I don't have any subject here, you'll see in a moment what the subject means. It will apply this comment to the whole page. In this case, it will look in the whole page for this text Rhino app. So if I just save it and go back to my Cypress window and fix it so it contains, which is how like it should be, you will see that the test will be now passing. I can take a look at this test here. I realize it's a bit small to see, and see that Cypress visited the root page and checked if the body of my application contains text Rhino app. Just to show you that it's not passing all the time, if I require this kind of title, Rhino apps instead, and just rerun it, Cypress will wait a moment because it hopes that maybe the text will appear, but it won't. So it says that this test does not pass. All right, so this is first task, to just check if the static title appears. OK, step 3. To greet, let's check if the application greets user with their name. And we are told to uncomment this piece of code. This piece of code is responsible for getting the greeting output from the application. The greeting output is defined here. And what might be interesting is that it has this app prefix. This is because the top-level module of Shiny, of Rhino application, is a Shiny module. And that module has this app namespace, which is hard-coded, and you can and should use it whenever you need to refer to something by ID. Always the ID will be prepended with this app prefix, and this hash here is just a selector. Give me the element with exactly this ID. And this test will now check if it contains hello Rhino. So if I just save it now, the test will fail because I haven't yet filled this step 3 here. What I need to do, I need to get the element with ID app name. And this is the text input that I have here. And I need to type something into the text input. And this is done with the command type. Now, if I save it, you can see that this test passed. And if you take a look here, you can actually see a replay of what's been happening with the application. Cypress first typed in Rhino into this field, and then waited to see if hello Rhino message appeared. And the last piece of this showcase, let's uncomment this line. Again, the test won't pass because now we are checking if the done field, the done field is here, it's a text output also, it should contain a message well done. But it does not because we need to check all the boxes to get this message. So how do we check all the boxes with Cypress? Again, we select by ID. And what we can put here is actually a selector. It's not just an ID. It can be any CSS selector and actually many more advanced things. But in this case, I want to select all inputs that are descendants of the app choices element. And to do it, I use this kind of selector. And then I use the check command. And this will check all the checkboxes. I don't need to know how many checkboxes are there. This will work because this selector returns multiple elements, and I check them all with this single command. And I need to fix this. And finally, you can see that this test passed as well. You can see that now Cypress automatically checked these checkboxes for me, and the test passed. So this is it for this kind of short presentation. Just to answer a question which I quickly see here, why not to use test that? So you can use test that, and using test that means probably using Shiny test 2 for having this kind of end-to-end tests. But as I mentioned, it works differently, designed specifically for Shiny applications, and it has its limitations. Many times they won't be a problem, but sometimes they will be. And Cypress, in general, as a quite widely used tool, is designed to do many difficult things quite easily. And to write some kind of tests, it's like really much easier to use Cypress. But it's not one or the other. You can actually use both Cypress tests in your Rhino application and also have Shiny test 2 if you wish. And of course, unit tests using test that in general is a whole other topic, which unfortunately I have not touched in this workshop. And you definitely should be writing unit tests using test that. So the answer would be use both, basically. They all have their place and purpose. All right. So this is it for the official workshop. Thank you so much for everybody who attended. Thanks for bearing with the imperfect task descriptions, with task descriptions which were not detailed enough. And sorry for planning so much for such a workshop. Really should have tested this more. And probably it was, in hindsight, it's obvious that it was a bit too much for this kind of short time. So thank you so much. I said that I will be still staying, if needed, to answer any questions that might have appeared and I might have not answered them yet. And I just wonder, thank you, everybody. It's really nice to see all those messages in the chat. So I wonder. I think let's actually. Veda, what do you think? Should we? Because I don't see, and it's hard for me to say if anybody's staying to listen to my answers right now. So I'm just wondering if it's better to wrap up and answer asynchronously later, or maybe it makes sense to have a kind of after party now and talk a bit more.
Maybe we should ask the chat. What do you feel?
Let's ask the chat.
Yeah.
Is anybody staying? Who would like to ask some questions or talk a bit more about the content of this workshop? Okay, I see there is at least somebody interested. I wonder, I see Joanna is also here. Is it possible now to maybe stop recording and let whoever wants to stay actually show their face and talk with us now? Okay. Meanwhile, as we're waiting for technicalities, I see some questions, so I can just start addressing them. Okay, we can't stop the recording, but we can cut the questions off in the... Okay, no problem. Anyway, if somebody would like to actually join us and talk with us face-to-face now, Joanna or Martin, please help us to do that. Regarding the questions, I'll just address the ones that I see. So, okay, regarding task 3, shouldn't we pass pool as an argument to all functions? I think it might be quite a reasonable design decision. I did it this way as one of the many simplifications for this task, so it could still kind of fit into this workshop. I think, yes, if you are actually building a serious application, you'll probably want to pass the data source to each function that needs that data source, because this will allow you to test those functions more easily. With this setup, it still will be possible by manipulating the config and whatever. But yes, definitely, that's a good point. I guess it all depends on how you are designing your application and what you are building it for. As a general rule, I think it would be a good choice. In this exercise, I made it this way to simplify things. I definitely didn't intend to show kind of bad practices here. So good point about that. But do you see maybe some other questions that we have not answered before?
I don't think so. There are some new questions now.
limitations of using session user data as global variables to be pulled by other modules. I guess I wouldn't call it as much limitations, but potential pitfalls. In general, using session data is much like using global variables. The difference is that whatever you put there becomes global to the whole session, not maybe the whole application, but it's almost it's a very similar case. And similar caveats that apply to global state apply here as well. If you have many global variables, it might get very difficult to kind of understand what's affecting what in your application. For example, if your functions rely on some global variable, whenever that variable changes, the behavior of those functions can change as well. And if you have multiple variables like that and multiple functions which use those variables, it will be very hard to debug your code in some situations. It will be hard to write tests for your functions and so on. So in general, it would be best to avoid this kind of global state. And this applies to session data in a very similar fashion. However, in some situations, I think it's the right choice or the best choice, given other options, to share some information between modules. For example, imagine that your application uses some data which is used throughout the application in many different ways. And you definitely want to fetch it only once because it's big, for example, and store it somewhere. And now what? If you want to have it available in all those various places in your application, you'll probably need to pass it around as arguments to your modules everywhere where you need it. And I would recommend it as the default approach, actually. Try it and see if it's bearable, if it's like if you can work with this kind of approach, because the benefit is that wherever you have a function defined, it explicitly takes that input. You can test it more easily and so on and so on. But in some cases, this will be hard to bear, and basically having this kind of solution will make your code even harder to maintain. And it might make sense to store some data in session data that is like global and you're going to use it everywhere. Probably, if you want to do that, you will want to wrap it in some way. For example, define some R6 object which has well-defined methods that give you the kind of data that you need, and make sure that you don't put just anything there, but only what's allowed, and so on. I guess it's quite a big topic and deep one to discuss, given both like the topic itself and how it relates to R, because R has its many quirks, including multiple object-oriented programming systems and so on. I'm just saying R6 might be a good choice here, but maybe not for other reasons. So yeah, not exactly limitations of using session data, but more like pitfalls. Avoid if possible. And if you need to do that because you tried the other method and you can see that it gets too complex, then definitely use some wrapper functions, whatever, to kind of make sure that your code is maintainable. All right, I hope that answers the question. Many more questions I see. Constraints with deploying Rhino apps via Docker. I'll quickly answer that there should be no more constraints than you have for a typical Shiny application. Maybe the constraint is that we do not have very direct support for that. You don't have any ready function to make Rhino into a Docker container and to just deploy it. But for example, the Rhino showcase application, which is linked from the Rhino repository, and it's meant to be kind of a showcase, how to use Rhino, how to build an application with it. It comes with a sample Docker file that shows you how to do that. And basically, you do that like you would do for any Shiny application. So I'll end this answer like this. Having installing Node.js packages with npm, will it install in some time? I hope so. It might take a while depending on your connection speed and how fast your computer is. The first time you are doing it, I think it's totally normal for it to take a couple of minutes. If it's taking a long time, maybe there is some underlying problem. If it does not finish in like 10 more minutes, then I would expect that there is some additional problem. You can ping us later or go to Rhino discussions, or, well, you can report a bug basically or ask for further help. Cons related to using Rhino. Well, certainly there are cons. There are pros and cons, I think. If I was to honestly answer this question, I think the biggest con is probably the complexity. You can certainly see that there is much more to Rhino than to a vanilla Shiny app that uses a simple one app.r file. But for the price of this complexity, you get all these features, which, as we worked in various projects for the clients that we had, we learned that we needed those features time and time again. That's how Rhino was born, by adding the stuff that we needed in pretty much all the projects. So I think this might be the biggest con, the complexity and everything that is related to that. I mean, again, having people collaborate with you on a Rhino application might be more difficult if they are not familiar with Rhino, at least at the beginning, because there is like more stuff to learn. There's a learning curve to it. But otherwise, I would say that in general, any cons that apply to Rhino probably apply to not Rhino as well, and to wider question of using Shiny and R, because Rhino is actually not that much different from plain Shiny applications. If you look at it closely, it kind of bundles many tools together. It bundles the tools that we found to work best together. It uses some default configurations for them and so on. But otherwise, it's still a Shiny application. And for example, when I answer how to deploy it, the answer will be, well, like another Shiny application, right? So I think this was maybe not a complete answer, but an honest one, and out of my head, what first thoughts. Okay, other questions. Can you just use helper functions of Rhino, but not the whole structure of the app? It will work for some of the functions, but not for others, because some of the functions make assumptions that a certain file, like config YAML, is in a certain place. And in general, Rhino is not designed to work this way. And I don't want to say never, but the idea behind Rhino is definitely to have a specific project structure and a set of functions, tools to operate on that structure. So it will probably stay that way. And I would say in general, you won't want to use Rhino without Rhino structure. Can you create a package from Rhino app similar like with Golem? It's a tricky question. We kind of, well, quick history. Why Rhino apps are not packages in the first place? As Rhino, if we look at the beginnings of Rhino, we actually had many predecessing tools to kind of fulfill the same need. We also considered maybe we could just be using Golem. In the end, we decided for a structure which does not use an R package. And one of the main reasons for that is that if you want to have an R package, you are forced into many choices. For example, you can only have a flat file structure under the R directory, and they are all included in the same namespace, which is totally contrary to what we have with Box and modules and so on. And we deemed that feature important, to be able to structure a large application using directories, files, and have separate namespace for each file, and so on. And there are many other choices that an R package would force us into. And we wanted to have the flexibility of not being forced into those choices. So by default, and yeah, Rhino application is not an R package, and it's quite far from it. So to answer if you could create a package from a Rhino application, I want to say that we also considered it, I think, more than once. And there are probably ways to force a Rhino application to be an R package, but I really wouldn't recommend it. I wouldn't see a point. The philosophy behind Rhino is quite different. And Rhino is not designed to be working as an R package. So a short answer to this question would be no, you cannot make a package of Rhino app, at least not simply and not by design. I also see a question about sharing variables between modules. This question has been asked several times. Any tutorial about added to the upcoming sessions? I'm not sure. Maybe it's more a question. Okay, maybe it's more a question to what's coming up in the conference in general. But I'll quickly say that I recommend to take a look at the documentation of Rhino. There are several tutorials, articles, and how-tos. The documentation could use a bit of reorganizing, but it does have some information about what you need here. So, well, definitely search if something is of interest to you. Can we have a look, a question from earlier. Can we have a look at how a user authenticates in Rhino user pass scenario? I think, okay, I think this question came up as we were talking about connecting to databases and using a local development database and a production database. Sure. Veda, thank you so much for helping us. I don't want to be keeping you because we have a workshop soon. So thank you so much for help. Yeah, good luck on your workshop. And yeah, thank you.
Thank you. Bye.
Okay. So back to the question. Authenticating users in Rhino application. This was asked when I was talking about databases and how you would define a production database config that would probably take things like user name, password, database name from environment variables. But I think this question actually turned into something slightly different, and this is about how to authenticate users to a Rhino application, meaning you launch an application and you see a login window. And actually, there are a couple of options to do that. It's possible to use one of the packages out there which were created for it. For example, I think there is a package called Polished. Another one, which I don't remember the name of. Anyway, go to Rhino documentation site. If you just search Rhino R package, you'll find it. And among the how-tos, there are articles called How to Use Polished and How to Use this other package, which I cannot remember. And they tell you how to use this kind of packages if you need the kind of authentication they provide. And they allow you to create a login window before you can actually access the application behind it. Learning curve. Any suggestion for helping Shiny dev team transition to using the Rhino framework? I think this would be I think I don't have a more general recommendation than ones that would apply to any other technology. Rhino is not yet popular enough to have like regular or very regular workshops like, I don't know, a Django in Python would have, for example. So I can't recommend your team to go to a training, but definitely maybe take a look if we are organizing any training soon and maybe suggest your team to participate. That's one thing. But otherwise, it's just like learning, I guess, any other technology. And I think the beginnings are always the hardest. I think it's important to have at least one person who will be kind of the ambassador of any new technology that you introduced. Somebody who will have enough time and who likes the technology enough to learn about it a lot and to kind of become knowledgeable about it and to guide the rest of the team into further learning that they will need to carry out to work with the technology. And as I said, I think this applies to anything, not just Rhino, but in particular to Rhino. So maybe you can be that person, maybe somebody else, but well, definitely somebody will need to be responsible for being the most knowledgeable person about it. That's at least my thoughts if how it can work. Probably I could talk more about it, but these are all opinions, so I'll stop here. Do we need to take anything into account when publishing Rhino app with Posit Connect? Again, there are some tutorials and we have some documentation about that, and you should take a look there, because now it's hard to come up from my mind with any specific things that need to be taken into consideration. Again, the same general rule applies that a Rhino application is basically a Shiny application. So it's not that much different when you are deploying it to Posit Connect, but there are some things to keep in mind. For example, Rhino uses Node.js, and it means that it creates some directory with a ton of files in there. And actually, by default, it's already configured to ignore that directory and not to deploy with that directory. But if you are doing something like that, like adding other big files, you'll need to take care of them as well. But again, this would apply to Shiny applications in general. So Rhino is designed to kind of work smoothly when deploying to Posit Connect, because this is what we typically use for deployment. And you should be able to just use it out of the box and you should be fine. Will anytime soon, are we going to create a Rhinoverse package that allows you to create desktop Shiny apps more easy than the actual alternatives? Wow, I have no idea. I mean, R and Shiny are predominantly web technologies. There is a lot going on recently in the topic of WebR, for example, and I think I've heard of packages which try to allow you to create a Shiny or R-based application, a desktop application, but honestly, I don't know enough about it to tell you more. Regarding Rhinoverse in particular, I don't think we have this kind of plans now. So short answer is probably no. Recommendation to deploy an app aside from server-side solution. I'm not sure if I understand that. Maybe it relates to Okay, so I guess the question is whether we can have a Shiny application without a server running behind it, without a backend. So it's a bit similar, different, but kind of same theme as the last question. As of now, no, but maybe in the future, because a lot is happening around WebR, which allows you to run R and Shiny entirely in the browser without any server backend. And maybe this will come to Shiny as well. So for now, you basically need a server somewhere. It can be Posit Connect, it can be Shiny Apps IO, it can be Docker container and Shiny proxy, but anyway, you will need a backend, at least now. Question. I've built Shiny Apps Predictive Analytics where I had to bundle up a bunch of models. Is there anything about Rhino that would interfere with that? I don't think so. No. You should be fine. Can you create a desktop Shiny app? Well, not sure if maybe I did not answer that question fully, the last one, but in general, I don't know of a ready solution that would allow you to do that now. So I don't want to say no, because certainly if you put a lot of effort, you can find a way, but I don't know how to do it in any simple way right now. All right, I think I answered all the questions, at least as I've been scrolling them. Sometimes it was not in order. If you have a question that has not been answered, you still have a chance to answer it now. If I don't see any question coming up within the next 2 minutes, I will assume that we are done here. So again, thank you so much, and thank you for asking all these questions. It was a pleasure to present for you and a pleasure to have so many people watching.